Hello. Hello and welcome to this short video on classes of JavaScript. We have covered up till now, I think, 4 or 5 parts. So we will finish the discussion on classes in this part and then we will move on to modules of JavaScript. So this part is specifically based on design. We are going to discuss the design part of JavaScript. Specifically, two things. One is inheritance, another is composition. Okay. And then there is another thing called aggregation. So there are three terms: inheritance, composition, and aggregation. There is a and has a mechanism also. So inheritance is an is a relationship. For example, suppose you have a base class or parent class car, and then you inherit from the car and make several different classes. For example, BMW, Volkswagen, Volvo, Mercedes, BMW, Ferrari, Rolls-Royce. So you can make several child classes out of one parent class, that is car. Now all these child classes, BMW, for example, is a car. Okay, Volvo is a car. So this is when you extend a class by the extends keyword or through the prototype mechanism, then that is an is a class. So inheritance by nature is a mechanism. Now aggregation is something different. Aggregation we don't do in JavaScript. So in aggregation, what you do is you have a pointer of a different class into a different class. For example, class car might include a pointer to an engine class, so that when you create the class in the constructor, you initialize this engine as well. You call the new method, for example, in C++ on the engine. So it is through pointers. You don't hold the object of the car, just the pointer to that. Since JavaScript does not have pointers, aggregation is not really possible. So now we have the car has the engine. Okay. So it is not an is a relationship, it is a has a relationship. Then the third thing is that you have composition. So in composition, rather than holding a pointer to the engine, you hold an object to the engine. So in a has a relationship, the cleanup of engine may happen elsewhere. It is not necessarily that you delete it in the car object. Usually you do it in the destructor, but it is quite possible that the object is created elsewhere. You don't necessarily create in the constructor, rather you assign from outside world. So that is a possibility. But in composition, you create the object of the car and keep it in the class of car. So when car object is created, engine is created, but when car is destroyed, engine is also destroyed. So that is the composition technique of object-oriented programming. You would hear a lot of times that you should do composition instead of inheritance. That is a valid argument. So we will look at an example of histogram class. So it makes use of the map. Okay, so it is composed of a map. So we have this dot map is equal to new map. For getting the count of a key, we get this dot map dot get key, and has key returns the count of the key, and size getter is returns the size of the map. The add key function, what it does is it sets a key value pair in the map, but increases the count of the key basically. Okay. Now count is nothing but this dot map dot get. Okay. Then in the delete, what it does is if the count of the key is there and it is equal to 1, we delete from the map. If count is greater than 1, then we set the key again with count minus 1. And the iterator on the object will give you keys. And then we have keys, values, and entries which iterate on the map basically. So classically, not classically, if you see this, then the two functions add and delete are providing the custom logic. And as is also different, count is also different. But in essence, we are using the map functionality to create this histogram and with our own logic. Okay, so that is our histogram class. Now I see that it relies on the map. So it is composed of a map, so it is composition. Now we will come to composition again after looking at this example. Okay, so another approach is there in which programmers create classes by inheritance. Now, what matters in inheritance is that you maintain a very elegant design. It is possible to maintain a very elegant design in classes. So suppose we have an abstract set. So usually in inheritance-based classes, you start with an abstract class. Normally you have, for example, in C++, you have a virtual function, pure virtual function. That is, the implementation is not given and you must override. So similarly, we have a has x method, which is not defined. It does not have logic. It throws another abstract method. Now, not set method creates this. So again, it is composed of set. We call the constructor of super, and we set the set number of this abstract set to a set of JavaScript. Now, has a returns whether set has that element or not and negates that with a not gate. And toString tells us that something is not in this set is what constructs this class. And similarly, we have range set, which we have seen earlier, a range class from 2. So it constructs between from and 2. And if the value falls between these two limits, it will satisfy has a. And the relationship is that x must lie between from to 2. Similarly, we can have an enumerable set which extends from abstract set. So size, we don't implement, again, remember that it is an abstract set. Iterator, we don't implement isEmpty, treats whether the size is 0 or not. And toString prints this. And equality tests whether the set which we are comparing with is the same class or not. And size should be also equal. And element of this should be present in the set element. Okay, whatever is of this class should be present in the set. And if all these conditions are satisfied, then we return true, else we return false. So you see that you can have multiple levels of inheritance in this, and you can create a very clean design and use that. Now I'll talk about the downside of inheritance. So I'll give an example, real life example. Once I was working for a company sometime around 2015, and I was supposed to fix an error which was coming in production. So I checked the log, filtered the message. Now the name of the class was there in the log, so I went and looked at the log. And I saw that the exception message is not there in the class. And the class had inherited from another class. So naturally, the flow of logic will tell me that it can come from the parent class. I looked at the parent class, it did not have the exception message. And then I looked at the grandparent, that also did not have the message. In this way, I iterated up to 8 levels of inheritance mechanism to find the exception message. So in the hierarchy of inheritance, the actual message was coming from 8 level above the object which was throwing the exception. You see, debugging can be a bit of pain, and trying to understand and remember the hierarchy of the classes when your program grows larger is quite painful. And that is why this notion came after we experienced the horror of inheritance, too much inheritance, that composition is a better form of object-oriented programming than inheritance. So whenever you are doing class-based design in JavaScript, always try to think whether inheritance is suitable or composition is suitable. You have to weigh very clearly, and you must be very decisive about what you are going to choose. I'm not going to say one is better than the other in all aspects, but the notion that composition is better than inheritance comes from experience. Okay, people have programmed for now 3 4 decades, and after that uh, programming, the wisdom came to them that composition is better than inheritance. If you are a new programmer, you do not have that 20 years or 30 years of programming experience, and therefore you might say that, oh, no, 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 inheritance is better than composition. So I will do inheritance based design. And once you do that, and once you see that there are problems associated with this kind of design, you will also realize that composition is better than inheritance. The main advantage of composition is that it keeps the inheritance hierarchy flat. As an example, I'll give you an exercise. Java has an SDK and it has an inheritance diagram for all the classes in the SDK. Just look at that diagram and try to understand that what is going on there. And you will be shocked that it is massively painful to look at that diagram and try to understand the logic out of that. So again, I will repeat this, that the notion that composition is better than inheritance comes from experience. It is not a theoretical thing, it is a practical thing. Object-oriented programming has got bad names because of this kind of design horrors, where complex inheritance hierarchy make it very difficult for a new programmer to understand the program. For example, Linus Torvald has said that he chose C just to keep the bad C++ programmers out. James Gosling says that I did not leave object-oriented in the hand of Java programmers because I see programmers abusing operator overloading. So see, one's experience uh, describes that what one has suffered from. So James Gosling might have seen people misusing operator overloading. Linus Torvald might have observed horrible programs written by poor C++ programmers. So it is from our experience that we learn that, okay, this is what that does not work, practically speaking. Theoretically, you can think of anything. Okay? There is no limit of what you can think in terms of theory. But practically, a program, when it has to be written, it grows into complexity. Particularly if you intend to do backend programming in JavaScript, then the logic can grow huge of complex web applications. And then if your design of the classes is not appropriate, you might shoot yourself on foot. And then you can't blame JavaScript. A language is a tool, but how do you use it is up to you. And sometimes it is better to just rely on the wisdom of others rather than going through the same pain. You might not have the same experience, but once you see the pain of others and you take the words of wisdom of others, you will save yourself quite a lot of time and effort. So that's all. As I said, it was basically, it is not a rant, it is basically practical observation. I was not ranting about object-oriented programming. So with this, I will end this video here, and you saw that JavaScript gives you features of composition and inheritance both. So choose wisely, and in the next video, we will start with the modules, and we'll see how we can create modules, and with ECMA 6, what modules bring to us in terms of syntax and usage. So I think in one of the programs I have shown the package.json earlier, and there I mentioned the keyword type property of that JSON was module. So what that property means and other things about module, we will slowly go into that and we'll study them. So I hope that you have learned something from this video, and it will be useful for you in practical programming. So thanks a lot for watching the video, and we will meet again after 4 days with a new video on modules in JavaScript. Till then, stay curious, keep learning, and most importantly, enjoy.